From navigating oceans under the stars to exploring the vastness of space, humanity's quest to find its way has evolved beyond imagination. This is the story of space navigation. At its core, navigation is about determining your position relative to a known reference point and charting a course towards your destination. On Earth, navigation relies on landmarks, compasses, and satellites. At sea, the stars and sextants guided sailors across vast oceans. A compass determines direction by pointing to magnetic north, helping navigators set and follow a course. A sextant measures the angle between a celestial object and the horizon to calculate latitude and longitude for positioning. On Earth, we use landmarks, maps, and GPS coordinates to achieve this. In space, however, things get a bit trickier. Since in space there is no north, south, east, or west. Instead, navigation depends on fixed celestial references such as stars and pulsars. In near-Earth orbit, navigation is relatively straightforward. Earth's gravity dominates and positioning is aided by ground-based systems such as tracking stations, radar, and GPS signals. Ground stations monitor satellite positions and relay critical data, while radar systems help with precise distance and velocity measurements. GPS signals, originally designed for terrestrial use, have been adapted to support satellites and spacecraft in low Earth orbit, providing continuous and accurate positioning data. Tools like star trackers map constellations to orient spacecraft, while onboard sensors and GPS adapt to provide positioning, guidance, and control. Lunar navigation is more complex. As spacecraft move further away, the time delay in communication signals increases, making real-time control more challenging. To navigate autonomously during lunar missions, spacecraft rely heavily on star trackers. Star trackers are critical tools that use celestial navigation by mapping the positions of stars to comparing them to onboard star catalogs to determine the spacecraft's orientation with remarkable accuracy. Onboard inertial navigation systems measure acceleration and angular velocity to calculate position and trajectory independently of external signals. These techniques are crucial for missions like Artemis and the Lunar Gateway, which serve as stepping stones for deeper space exploration, providing essential infrastructure and experience for navigating beyond Earth. Interplanetary navigation extends beyond Earth's influence. Navigating the vast distances between planets and venturing into the depths of our solar system present even greater challenges, demanding innovative techniques and advanced technologies. These missions, often lasting years or even decades, require exceptional precision and redundancy in their navigation systems. A slight miscalculation or equipment failure could have catastrophic consequences. One promising avenue lies in utilizing pulsars, rapidly rotating neutron stars that emit beams of electromagnetic radiation. These beams, like cosmic lighthouses, sweep across space with incredible regularity. By analyzing the arrival times of pulsar signals, spacecraft could determine their position in space with unprecedented accuracy. Spacecraft rely on Hohmann transfer orbits to efficiently move between planets. This technique involves using the spacecraft's engines for short bursts at specific points in its orbit, like paper in the wind with boosters. Gravitational assists from celestial bodies to gain momentum, speed, and trajectory. By carefully planning flybys near planets, spacecraft can gain or lose speed without expending significant fuel and radio signals combined with the Doppler effect to precisely track their position and velocity relative to Earth. From the oceans to the stars, we've uncovered the tools that guide us. We've scaled from the comfort of Earth's orbit to the distant reaches of interplanetary space, relying on critical infrastructure like the Deep Space Network and cutting-edge techniques like Hohmann transfers and gravitational assists. Future missions will demand innovative navigation solutions, pushing our technological boundaries. What topics should we explore next?